Okay, the next tutorial that we're going to look at is involving logarithms. Now you probably haven't seen logarithms before or you haven't used them very much, so let's go over what they are and what they're used for. So I'll start with what they're actually used for. Basically, logarithms are used for when we want to solve for a variable in the exponent. So let's say I had 5 and I want it to some power equals something. And in this case, I'll put it to something that we actually know. So 5 to the power of something equals 25. Now we can all look at that and know that 5 squared equals 25. So therefore, x must equal 2. But what if I was to do it again and I said 5 to the power of x equals 30? Now, whatever that exponent is, isn't necessarily going to be a nice number. So we know 5 squared is 25. If I went 5 to the power of 3, that goes all the way up to 125. So it's definitely going to be bigger than 2 and less than 3. And since 30 is close to 25, it's going to be closer to 2, but I'm just guessing at what exactly it is. So logarithms are actually used to solve and find the exact value of an exponent. Okay, so the first thing we need to do before we even get to the solving stuff is go over how we can use this new operation logarithms. So let's start by saying if we had something like x equals b to the power of y. So I'm doing this in general. If I do this, b is the base, y is the exponent or indice, and we'll just call x the value or the number. I'm just going to write number. So it's basically that the base to whatever exponent equals an answer. So it's just going to be some value or some number. I'm just going to call it number. If I want to do this in logarithmic form, so I want to use the calculator to help me solve for whatever that exponent may be, what we would do is we write the log of the base, so that's a little b there, of the number equals the exponent. So by changing it from this first form here to this second one, I am solving for the exponent. So I've gotten y out of the exponent, and now it's y equals something that I can do on the calculator to find what that exponent is. And just for your information, the top one here is called index form, and the bottom one with the log in it is called logarithmic form. So I know this is all new to you, so we need to practice switching in and out of these forms before we even look at solving anything. We need to get comfortable with going from index form into logarithmic form. So we need to be comfortable with switching back and forth between these two. So let's do some examples of that. So my first example is going to be a to the power of x equals a capital R. So I'm not looking to solve anything here. All I want to do is change this from index form into logarithmic form. So what we do, first of all, we'll do it for the first couple here, we need to identify what's what here. So remember, a is the base, x is our exponent, and r is the value or the number. So when we change it into logarithmic form, so we've got it here just above us, all we need to do is write the log of the base, and in this case the base is a capital A, and then we put the number, and in this case the number is r, equal to the exponent, which is x. So if I had a to the x, a to the power of x equals r, that's the same as log base a of r equals x. And I'm not sure if you could see it from when I wrote it above or not, but the base always goes a little bit lower than the word log, and it's a smaller letter and then the number. I'll try to show it a bit more in the next one. So, example 2. Let's say I had 4 to the power of x equals 100. And I want to change this into logarithmic form. So I always start by writing log. Then I need to write the base, and this time the base is 4, so I'm going to try to write it even smaller this time and down a little bit, 4, of the number. Remember, the number is what was on the other side, so 100 is equal to my exponent, x. Let's do one more like that, but we're going to switch it from the other form. So I'll write logarithmic form, and we'll switch it back into index form. So the log of base 7 of 75 equals y. And what I want to do for this one is change it back into index form. So to go back into index form, we write the number first, and in this case my number is 75, equals the base is 7 to the exponent, and the exponent is y, because remember logs always equal an exponent. Alright, now that we've practiced just switching back and forth a couple times, you might want to practice that, you might want to pause this and practice that a little bit more. Let's go to doing some where we're actually finding an answer. So for the next one, let's try to actually find a value of something. So let's say we had log base 2 of a capital B equals 4. So log base 2 of some number, b, is equal to 4. And remember, 4 is the exponent. So in order to solve this, I need to change it back into index form. So we start with writing the value, the number, and then in this case the number is b, we don't know that, equals the base 2 to the exponent, and the exponent was 4. So I can evaluate 2 to the power of 4, that's 16, so therefore b must be equal to 16. Let's do another one that we can solve easily enough. So example 5. Let's do log base 3 of 27 equals x. So this time I'm in logarithmic form, as I was in the previous one, but it's the exponent that I don't know what the answer is. So I know the number, I know the base, but I don't know the exponent. So since we haven't went over how to do this on the calculator yet, but just changing this back into index form, I get the value, which is 27 equals 3 to the power of x. Now in this case, this is a nice value. 27 is equal to 3 to a nice even power. So 3 times 3 is 9, times 3 is 27. So that's 3 times. So I know just looking at it, without doing anything on the calculator, that x equals 3. Alright, let's do a couple more examples. So let's say I had log base 10 of q is equal to -1. So the first thing we want to do is change this back into index form. So that's the value, q, is equal to the base 10 to the negative 1. And 10 to the negative 1 we could write as 1 over 10, or if you like 0.1 if we were going to write it as a decimal. So that was example 6. Now how about another one? Let's do one where we're solving for a base. So log base x of 0.25 equals negative 1. So once again, we're going to change it into index form. So when I'm changing it into index form, I have the numbers 0.25 equals x to the negative 1. Now, in order to solve this further, we need to remember from a previous lesson what a fractional exponent means. So remember, negative means reciprocal. So negative 1 means 1 over x. So I have 0.25 is equal to 1 over x. And then the next step, if I want to get the x by itself and rearrange this, is to switch those two, like cross multiply. So x equals 1 divided by 0.25. And 1 divided by 0.25 is equal to 4. Okay, I'd like you to give the next section a go, doing the questions assigned. So it's switching between index form and logarithmic form, and if you do need to solve anything, it should be something that you can do that works out nicely. So it won't be anything that you require using the calculator or the log button for yet. We will be looking at how to use that and some other properties of logarithms within the next couple tutorials. Thanks.